Okay, thank you very much, everyone, for being so punctual and getting back over here and helping get us a bit on time. I would like to call up my colleague at PEO, Jeanette Chow, the manager of our student programs, to introduce our award winner.
Hello, everyone. I'd like to introduce Lesley Herstein to you today. This morning we saw in Dr. Patry's presentation that Canada lagged behind many of the other countries in the number of PhD students that we graduate. Well, I'm happy to say that Lesley is a PhD candidate, one of our few, in the Civil Engineering Department at the University of Toronto. She's also the winner of the Ontario Centre for Engineering and Public Policy's 2011 Student Essay Competition. Her research examines Ontario's water infrastructure deficit as a dynamic and complex problem that requires reformulation. Ms. Herstein is exploring how such a reformulation creates the potential for engineers and engineering to play a key role in building the capacity of Ontario's water providers to better address water infrastructure funding issues in the long term. Before Lesley begins her presentation, however, we'd like to present her with the award as the winner of the 2011 Student Essay Competition.
We'll all zoom in with you there. That's great. Congratulations.
Thank you very much.
I'm really sorry I can't stay for your presentation.
Oh, that's okay.
But
Can read the paper.
Yeah, but
Thank you. Thank you very much. So I would like to thank the Ontario Centre for Engineering and Public Policy for giving students the opportunity to, I guess, voice a lot of what maybe we think about in class or at our desks in our small offices at the University of Toronto, where nobody wants to talk to us. And allowing me and others to, have a forum to share ideas, and some of them, might be a little zany, but they're ideas nonetheless. And I think innovation comes from ideas and sharing ideas, and this is a forum for sharing them. So I'm going to share some of my ideas with you today, and that's how we will start. My essay talks about the infrastructure funding gap or infrastructure deficit as it pertains to water utilities, basically in Southern Ontario, larger water utilities. And we do have a problem, and I think a lot of the things that I touch on in the presentation today have been touched on in the morning. So the problem is that we put a lot of money into infrastructure and a lot of thinking into infrastructure post-World War II, and then we kind of let it sit there. And now we're at this point right now where we're going to have to make a lot of very important decisions. And engineers can be part of that decision, but the idea is sort of we might be part of that decision, but we need to make sure that that part is a good part and is a helpful part, which might involve a bit of a paradigm change on our side. I guess we'll go this way. So the water infrastructure deficit in Canada in general, for just existing infrastructure to fix it, this is a 2007 estimate, is $31 billion. And I included all the numbers, all the zeros in there, so you could really get an idea for what that might mean. And that has definitely gone up. So every year that price goes up. And then another $56 billion for new infrastructure, so to make sure that we can meet our new demands, expand our systems, new treatment facilities, and that's just for that's drinking water and wastewater put together. I'm going to talk mainly about drinking water, though. So when we don't spend that money, what happens is the systems start to deteriorate, okay? And that means that you get more failures more often, and they become more serious, because the longer you leave the infrastructure and don't do anything to it, the worse the problem gets. And that has serious implications, economic, environmental, and health consequences that can be quite serious, especially the longer you leave the infrastructure. We talk a lot about dollar values and this water infrastructure deficit. It's become almost an empty term like sustainability or something like that. And we tend to focus on ideas that are financially based. So, public-private partnerships, alternative financing and procurement. How are we going to fund this? Where is the money going to come from? But I'm going to argue today that although, yes, this is a problem, it's actually a symptom of a greater problem. And much like if you have a disease, the symptoms start to come up, and you can, fix the symptoms or address the symptoms all you want. But the underlying disease or problem is still going to be there if you don't address it. And that's sort of the problem with focusing just on the money aspect of things, or the financial aspect of things, or the economic aspect of things. And not only is it a symptom of a greater problem, it's actually a symptom of a greater set of problems. And that problem is quite complex. And much like this man is sitting here in front of this crazy board, that complexity makes this a perfect problem for engineers, but it also complicates the problem, obviously, because it's complex. So I'm going to try to simplify that problem for you today and explain it in the most simple terms I can. And then I'm going to end with sort of the engineer's possible role in addressing the complexity of that problem. So at the simplest form of water distribution systems, we have pipes. That's supposed to be a pipe with water in it. And as engineers, I think we tend to focus on the system, so the pipes, the pumps, the tanks, the reservoirs, and all the optimization that might go along with that. There are also users, so we have a lot of demand-side management or soft water paths that are starting to be talked about and implemented in different municipalities. So the user ends up being part of that physical and operational side of the system. Another part of the system is the source, and I think post-Walkerton, the source-to-tap approach has been popularized, and it's worked quite well, especially for conservation authorities are a really good example of addressing that from a watershed basis and water quality basis. There's also the financial side of the system. Okay, so how do we finance the system? Where's the money going to come from? Are users going to have to pay more? Are we going to allot more property taxes? And then we have something that I think we forget about as engineers, but not here, obviously, is the institutional side of the system. Okay, so we have our federal, our provincial, our municipal governments, whoever they may be, and also the utilities or corporate utilities, or just put a box around those, or our municipal councils, public works departments, whoever may govern that system as a whole. And although all of these are shown sort of separately, they are connected, and they're connected in time and space. And they're complexly connected. You could start to draw arrows, but it could get very complicated, much like the recent, we saw a slide before that had all those little arrows. So it's a special type of problem. It's a complex system, or a complex adaptive system, if you want to use the correct terminology. But it's a special type of complex adaptive system known as a social ecological system, which is a term I've sort of borrowed from ecology, from ecologists. But this term, or this type of system, can be applied to political systems. It can be applied to all different types of systems, and I'm going to explain a bit more about what a social ecological system is. The social ecological system consists of two subsystems. This is very simple. An ecological subsystem, so the soil, the trees, the birds, everything that sort of affects the quantity and quality of, in this case, water. Okay? And the social subsystem is everything else. So it's the system, it's the policymakers, it's citizens, it's finances, so every other part of the system that does not fit into the ecological subsystem. And these two systems interact very complexly on different time and space scales, and within themselves is also with each other. Okay? The engineer is part of that social subsystem, which I think we forget sometimes. So not only do we affect that social subsystem, but we're affected by it. And we also affect the ecological subsystem, and that ecological subsystem affects our designs and our paradigms. So if there's a groundwater system, that's going to affect the way that we design the system. If it's a surface water system, if the system is polluted, right? So that's going to affect the way that we design things. One thing about the social ecological system is that the system whole is greater than the sum of its parts. So you cannot address each thing separately, which is the danger in addressing just the financial side of the system. Because another problem is just going to pop up, and it's like that game where you just keep punching things and things keep popping up again. The other thing about the social ecological system is that its combined success is based on the aggregate, so how it behaves together as a system. It's evolutionary, so how it changes over time and adapts, and it's anticipatory strength. So that means, the system has to be able to anticipate change in the near and far future. So that could be political change, it could be climate change, any type of change that might affect the system as a whole. And it's important to be able to anticipate that and react to that on a continuous basis. Now I put the term resilience in quotes because I think that resilience is becoming a term similar to sustainability. It's becoming sort of an empty meaning word, and language is very important, which I think we also forget about as engineers. From an engineering perspective, resilience is bouncing back after shock. So how long it takes to recover after failure. So if there's some sort of terrorist bombing, how fast can our water system react to that? Okay? But there's a second part to resilience that has been added by ecologists, specifically Halling in the 1970s, that has sort of taken over the idea of resilience, and that is that there needs to be a continuous building and utilization of adaptive capacity. So that system, although yes, you want it to recover from shock and bounce back from shock, the last thing you want is for it to return to a state that made it vulnerable in the first place. You want to change, you want to adapt over time, you want to be able to respond to new and more serious impacts of climate change or whatever else you might be thinking of. So I'm going to explain the complex problem that I showed you with the picture of Stephen Harper and his cat, and how you can sort of segment that system into different parts and focus on the resilience of each part of that system. So if we go to that diagram again, just to overview, we have physical and operational resilience, so that's the system and the user. We have the institutional resilience again. We have financial resilience. And we have ecosystem resilience. And although I've shown each of these separately, I just want to iterate that they are all connected. So I've segmented them to make the explanation easier, but you have to understand that they are all related. I had to group together physical and operational resilience and institutional resilience because there's a bit of a background historical story that combines the two together where water systems in southern Ontario are concerned. There's a timeline. So we start with World War II. So before World War II, there were a number of private systems, privately run, not a lot of public involvement in water provision, maybe a few systems, that's it. After World War II, there was post-war economic development. This was mentioned before, but we wanted to take advantage of the post-war economic development. And so what happened is that in 1956, the Ontario Water Resources Commission Act created the Ontario Water Resources Commission, which essentially dealt with everything in southern Ontario that had to do, in Ontario in general, that had to do with water provision and wastewater handling. So they built systems, they owned them, they operated them, they did research. It was a very vibrant, internationally recognized, amazing group that did a lot of very amazing things and built most of southern Ontario's water infrastructure in a period of about 16 years. I believe due to, it's hard to find this in the literature, but I believe due to political issues over time, the OWRC was dissolved into the newly found Ministry of Environment in 1972. And although the Ministry of Environment did deal with water-related issues, very little work was done on water systems. I think the idea was that they were in the ground, they're doing well, the OWRC did a great job. So all of that research and development and feedback and changing the systems and treatment, all of that basically came to a halt. The Ministry of Environment had a bit of a problem, and that was that not only did it own and operate and do everything with systems, but it also regulated them, so there was quite a bit of a conflict of interest. So the idea, sorry, I forgot to mention this, there's the problem with developing all the systems in 16 years and then stopping this development and stopping all the research is we then entered into a stage of what I like to call, and what I borrowed from a paper from the Ocepp policy journal, is infrastructure destiny, and that is that we've built these systems in 16 years. They were built mostly by the same people with the same ideas in that same amount of time, 1956 to 1972. And very little has changed. The same consulting companies have been working with the same systems. The same engineers have been learning about the same systems. And so it's created this sort of paradigm that is very difficult to shift away from. So infrastructure destiny, really great term. The MOE wasn't able, they had a bit of a conflict of interest, so the ownership and the operation of systems was then transferred over to the Ontario Clean Water Agency through a new act at that time. That didn't last very long. They weren't given a lot of funding to deal with the systems, so you have a bit of a shuffling of responsibility that you start seeing over this timeline. And eventually the Municipal Water and Sewage Act transferred those systems, the responsibility, the ownership of those systems to municipalities. And although the OCWA does handle a few systems still, the operation of them, all of the responsibility, financing, all of that stuff is basically on the shoulder of municipalities at the moment. And that created a bit of a problem because municipalities were given this new responsibility, but we're not really given the funding to do so. And so, which I'll talk about in a bit, we have Walkerton in 2000, and the effect of Walkerton obviously was to shed light on this issue of municipalities and the shifting of responsibility, but also a lot of regulations have been handed down to municipalities from the province in response to this, and it's been very difficult to meet those regulations. And it's also just been difficult to deal with an uncertain regulatory body. When you don't know what regulations are coming your way, it's very difficult to plan for them. And so that is sort of how the institutional resilience, so the way that the system has evolved over time institutionally, has changed with the transfer of the systems from, the province to the municipality over time. And then that has affected the physical and operational resilience because over this time, those systems haven't really been upgraded because there isn't a lot of money or institutional power to do so. So we head to financial resilience. So just as I mentioned, a lot of responsibility has been going from the province to the municipalities, which was mentioned earlier. Municipalities don't have the same kind of revenue sources that the federal and the provincial government have. They're quite limited. We saw that pie chart before with 8% of tax revenue that goes to municipalities. So it's just property taxes and user fees. So that's why user fees keep going up, because it's very unpopular to raise property taxes. It's a very inflexible way of funding your municipal infrastructure. And I think the Federation of Canadian Municipalities, in a report that they put out in conjunction with the Munk Centre, is that this type of infrastructure, or all infrastructure, basically municipal infrastructure, is turning into economic black holes that consume tax revenue rather than economic engines that create wealth. So they're becoming a liability instead of an investment. Another aspect of financial resilience is the user side of the system. We use a lot of water in Canada. We use about 260 litres per capita a day. That's a 2004 estimate. And in the UK and Wales, they use about 154. So we use way more water than we essentially need to. That is changing. Increasing user fees tends to decrease use. So that's one aspect of financial resilience. If you change the demand of the system, it is quite possible to change pressure demand on the system in peak times, which means that you can let your systems go a little bit longer. Systems are leaky, so there's pressure management either through demand management or through different types of new engineering approaches. So that's another way to sort of head off the major capital investment that you may want to make. Then there's ecosystem resilience. So I'm talking about the whole ecosystem, so the soil, the water, everything that affects the quality and quantity of water that we receive for our systems. And we put a lot of pressure on that ecological subsystem with pollution and drawing from the source and doing whatever. So it's very important to have some sort of monitoring, evaluation, adjustment. We have to be able to adjust to our ecological subsystem that we depend on quite heavily. Because if we don't, that ecological subsystem is going to start pushing back on us. I like this quote: engineers make things run, but engineers rarely run things. This is a consulting engineer in the US. I believe he's a structural engineer. So now I'm going to get to the idea of building resilience and the role of the engineer in that, because don't forget, the engineer is part of this social subsystem. And other people are part of this social subsystem, and we're not very good at working with other people sometimes, I think. They're lawyers, economists, citizens, ecologists, politicians. So we need to be able to work with those people in order to make these decisions, because they affect everyone and they are part of that grand system that we're a part of. And all of those people's decisions affect our decisions, and our decisions affect those people's decisions. So it becomes very complex. Our current practice is the end-of-pipe approach, and this is in two ways. So we're treating the symptoms. We're treating the infrastructure deficit. We're designing new systems. I think as engineers, we're also at the end of the pipe. So we're sort of on the consulting end of things where water systems are concerned. We end up at the end of that chain where all the decisions have been made, the regulations come down from the province, all the decisions get made at the municipal level, and then a request for proposal goes out, and we have very little influence over what that request is and how it gets filled, and so there's a role of consulting engineers to play in all of this. So the potential role is to recognize the complexity of this problem, to really understand what the problem is. And that means that we have to go way beyond problem solving, which I think is what we often describe our profession as. We solve problems. But we have to also take part in problem definition. So instead of participating in the discussion, we need to initiate it on a lot of levels. And we sort of need to redefine the asset in asset management. What are we managing? Is it the system, the physical system? Is it the source? Is it the institution? Who knows, right? And we have to develop a better understanding of that social ecological system and how to develop it in an aggregate, evolutionary, and anticipatory way. Because technology changes every 5 years on average now. Politically, we change every couple years now. So those things are things that affect our system, and we have to be able to respond to those things. And the system physically has to be able to respond to those things as well. So as engineers, I think that we're looking at engineering a better Ontario together. I think we need to ask ourselves how we're going to engineer that better Ontario. What is it going to look like, and who are we going to be working with in order to achieve what we want over time? And that is about it. So I can't actually take any questions, I think. But I would like to acknowledge a few people, or a few bodies. So one is NSERC. They fund me, so I definitely have to praise them. Professor Adams from the University of Toronto's Civil Engineering Department, who's my professor and has basically let me do what I need to do this, as well as the Ontario Centre for Engineering and Public Policy, which has given me the opportunity today to talk to you about this. So I'll leave my email up there, and that's it. Thank you. Oh, thank you very much.
We have another gift for you, Lesley, and thank you very much for an excellent presentation. It was really tough going through all the student papers. We had so many excellent submissions, and congratulations. Anybody who hasn't had the chance to read it, click on the Ocepp website and see Lesley's paper, because it was extremely well done.
Thank you very much.
Lesley.
Thank you.